This is going to be the video for the HMI panel mount. We're going to be using the sheet metal application in NX to make this. So this part is going to be in inches. We can just use the sheet metal. We can start with the sheet metal application here. Make sure we're saving this to a location that we can actually access. And we can just name this panel mount. We'll start with a tab. The thickness here is 0.125, 1/8 inch thick. We'll check our preferences to make sure that our sheet metal thickness is assigned correctly. And we'll start with a tab of 10 inches by 9 inches. So we'll start with this as our whole tab. This is our flat pattern right here. And we can see where the bend is located at. So this is, we're looking at from the top view of our flat pattern. So 10 inches by 9 inches for our tab. So let's go to File and then our preferences for sheet metal. Make sure that our material thickness and our other parameters are 0.125. Say OK. We'll start with a tab. Now, notice with the tab that the sheet metal thickness has already been assigned. So we'll select a 2D boundary, or in our case, we will create a 2D boundary, and that's going to be given the thickness of our sheet metal. So NX uses this thickness value to determine, all the bends and everything else that go into making these sheet metal parts. So it does a lot of the calculation stuff for us, which is helpful for stuff like this. So for the curve, we will say sketch section. Sketch on our top plane. And we're going to make a rectangle starting at the origin. And this is going to be 10 inches by 9 inches. Sketch is fully defined. We will say finish. And there it is, given the thickness of 0.125. If we needed to change this later on, let's say that we kept it at the 0.1, that was default, and then later we decided, oh, well, we need to actually make this thicker, use the thicker sheet metal, we can come in here and change it and it would automatically update. So not the end of the world if we do not do that, but since we already know the material that we're using, let's go ahead and add it in. So we'll say OK. And there is our blank tab that we're going to be using. Let's add in these holes first. So we have two 0.344 diameter holes. They're located 0.75 inches from the bottom surface, and they are 6 inches apart symmetrically along the part. So in NX, we will go to the modeling area where we have more, and we want a hole. Simple custom hole is fine, and we'll say 0.344. We're going to go to sketch section, and we are going to sketch on the top surface of the part. Now this is the 10-inch length, and this is the 9-inch length. Okay, so we're going to be referencing this, the bottom area here. So I'm not going to put down 2 points yet. What I'm going to do is actually place down a line. I'm going to add in a distance of 0.75 from the bottom of our part. And this needs to be aligned centrally to our part. So I'm going to say use our make midpoint aligned, and I'll pick up the midpoint here of the line that we just added, and I'm going to select the edge of our tab. So if you cannot select the edge of the tab, make sure that you're within work part only and not just the active sketch. So we want to change our scope to within work part only and pick up that line. You could also pick up the bottom line as well. Either one will work. Make sure that's aligned, and we're going to give this a distance of 6 inches. And this is just going to be used as reference geometry so we can locate the points for our holes. So we're going to make that reference geometry, and then I'm going to add in the points for the ends of this line. So there's our 2 holes. Sketch is fully defined. I'll say finish. These are through body. We're subtracting material. I'll say OK. There are our holes for the panel mount. Now let's look at this rectangle that's removed. Now this is going to be where the HMI is actually, mounting to the panel mount here. So we have a 7.46 by 5.5 rectangle that is being essentially removed from our tab here. Now this is not a hole, so we're not going to use the hole tool for this, but we're also not going to sketch and extrude. Instead we're going to use what's called the cutout. Sort of similar to the extrude when we subtract material. But it's a little bit different. So normal cutout is what we want. I'm going to say normal cutout. It's asking for a sketch, so we don't have one yet. So for this selection, we'll say sketch section. And we want to sketch on this top face again. And we'll make a rectangle. Now this rectangle is also located centrally along the part. So I'll say make midpoint aligned, the midpoint, and that top line. Say OK. And the size of this is 7.46 by 5.5. I'll go ahead and say 7.46 by 5.5. And it is located an inch from our top surface. So this line to this line will be 1 inch. Our sketch is fully defined. We'll say finish. And our material has been removed. Let's look at these cutout properties though. So we have cut method. This has to do with sort of where the sketch for the cutout is located at in respect to what you actually want to be removed. For us, the thickness is what we want. And then the limits here, so the limits are, value, you have a value between until next and then through all. So if you just want to remove like that one sheet of sheet metal that you want to remove, you're going to do until next. So until next just goes to like the back side of the material and removes that. For this part here, we could say through all and still it'd be fine. Most of the time for us though, until next is what we're looking for. So we just want to remove that one piece. So we'll say okay. So now let's look at these edges. So we have these rounded edges. So they are 0.5 inches. So we're going to go to our break corner. And we're just going to break the corner of all 4 of these edges here. 1/2 inch radius. Now we're almost done. Right now it's just a flat sheet. We need to add a bend into this. Now what we've done before is where we've done like a tab and then a flange, and that could have worked here just fine. But I'm gonna look at it, show y'all another thing here. We've identified that this area here, like this front area, is 1/2 inch. So the bend happened, or 1.5 inches, sorry. The bend starts at that 1.5 inch value. So that front face is 1.5 inches, and then the bend occurs. It's a 30-degree bend. All right, so let's see what we can do about that. So we'll look up at the bend area up here. So we've got bend, unbend. We've got some more bend options that are available. We just want bend. Bend is where we get to select a line or a curve, and we're going to bend the sheet metal along that line and specify what's actually being bent and everything. So we do not have the line on our part yet, so that line is going to be at 1.5 inches from the bottom of our panel mount here. So we're going to sketch that line in. So on select curve, we're going to say sketch section. And I want to sketch my line on the top surface of the part that we have. I just want to make a line going from the edge of our part to the other edge of our part here. I'll do a make coincident to tie that in. And this line is going to be 1.5 inches from the bottom. Sketch is fully defined. I'll say finish. And so here is where our part is being bent, okay? I kind of want to change this though. So I want the bend to be slightly different. So the angle is 30 degrees. That's what we want. So we want this bend to be angled to be 30 degrees. But instead of us bending up this side, right, I want this side to remain flat, and I want us to bend down the other side here. So let's see, if we reverse direction, okay, now we're reversing whether we're bending up or bending down, okay? If we reverse the side, now we're reversing which side is being bent down. So I reverse the direction, and then I reverse the side, and now we're bending down the other side, which is what we want for this. Now the next that we have is the inset, and this is just like the inset that we talked about with the flange. So if we kind of look at our bend line here in our face, kind of see the difference between maybe something like material inside, where now all of the material is on the inside, like the bend is on the inside, versus outside, where the material, if we follow the end, that's where the edge is lining up. So versus material inside, where the inside of the material is being lined up. We want this edge to be, so we want the bend to start at the 1.5 inch line, which is what we have here. So if we do outer mold line, that is where the bend is starting at the edge of our 1.5 inch distance, and that's what we want. So 30 degrees, we reverse the direction, reverse the side, and our inset is going to be outer mold line. We can keep the rest of the defaults here, that's fine. We can say OK. And that's what we're looking for. We've got a 30-degree bend at 1.5 inches up. Only thing left to do is create a flat pattern of this and export that flat pattern. So we'll create a flat pattern. I'll choose the tab here. So this 1.5 inch distance I just added, I'll choose that as the upward face. We'll say OK. And then we'll export our flat pattern as a DXF. Okay. So there is that DXF. And we'll need both of those things for this assignment.